When children compare decimals, they use ideas that make sense to them. In this video, I'm going to break down some of the most common mistakes students make when comparing decimals. The first way I'm going to look at is what's called whole number thinking. This is where we treat the portion of the number to the right of the decimal point as a whole number. Let's suppose we want to compare 2 and 352 thousandths and 2 and 4 tenths. With whole number thinking, that portion to the right of the decimal point gets treated as a whole number. When students make this mistake, they're thinking about comparing 352 to 4. They can see 352 is larger than 4, so they say 2 and 352 thousandths is greater than 2 and 4 tenths. However, this is an incorrect way of thinking about the problem. When students think this way, they often think that longer decimals are larger than shorter ones, which is not necessarily true. Another common way to think about comparing decimals is what's called the column overflow thinking. In this case, students name decimals incorrectly by focusing on the first non-zero digit to the right of the decimal point. For this, students would say this is 2 and 34 tenths, which is incorrect. But because they're thinking that way, they're going to compare the tenths. Because of this thinking, they are comparing 34 tenths to 5 tenths, and they can say that 34 tenths is greater than 5 tenths. So they would say that 2 and 34 tenths is greater than 2 and 5 tenths. But this is incorrect. This is actually 2 and 34 hundredths, not 2 and 34 tenths. Usually, students will identify longer decimals as larger unless there are leading zeros. As an example, with this particular thinking, students will say 2 and 5 tenths is greater than 2 and 6 hundredths because of that zero after the decimal place, and they name them by the first non-zero digit. The next method students may use is what's called denominator-based thinking. With this thinking, any number of tenths is greater than any number of hundredths. Any number of hundredths is greater than any number of thousandths. For this, 5 and 47 hundredths, students would focus on the fact that that is hundredths, place value. For 5 and 632 thousandths, students would focus on the fact that those are the thousandths, place value. With this thinking, students recognize that since hundredths are bigger than thousandths, we would have 5 and 47 hundredths are greater than 5 and 632 thousandths. However, this is also incorrect. With this type of thinking, students often think that shorter decimals are larger than longer decimals. The next way students often compare decimals is using what's called reciprocal thinking. In this case, students see the portion of a decimal to the right of the decimal point as a fraction formed by taking the reciprocal. For this one, let's think about 2 and 3 tenths and 2 and 4 tenths. With reciprocal thinking, students think of these incorrectly as fractions. They see these as 2 and 1/3 and 2 and 1/4. They then recognize that 1/3 is bigger than 1/4, so they say 2 and 3 tenths is greater than 2 and 4 tenths. However, this is also incorrect. Students will often say that shorter decimals are larger using this thinking, except in the case of those zeros directly after the decimal point. The last way we'll look at is what's called money thinking. This is where students just truncate the decimal after the hundredths place and view the decimal in terms of money. If two decimals agree to the hundredths place, the students will simply guess which one is greater, sometimes guessing correctly and sometimes incorrectly. For this one, let's consider 2 and 738 thousandths and 2 and 731 thousandths. For money thinking, students just drop everything after the second decimal place. Therefore, they see both of these as 2.73, and then they'll just guess. They may guess correctly, they may guess incorrectly. Money thinking isn't a horrible way to think about comparing decimals. Money is tangible and something we deal with on a daily basis. However, it is important to structure that thinking and make sure students understand that decimal places do continue to exist past the standard 2 decimal places that we use with money. All of these ways of thinking are not careless mistakes. They are reasonable ideas based on experience. Our goal is not to correct quickly, but to listen carefully and respond with models. When students feel safe explaining their thinking, real understanding has room to grow.